Hello everyone. This is day 25, question 1 of our Leetcode activity. Longest continuous subarray with absolute difference less than or equal to limit. So, we are given an array of integer nums and an integer limit. Return the size of longest non-empty subarray such that the absolute difference between any two elements of this subarray is less than or equal to limit. So, what exactly is the question? The question is we have to check all the subarrays, and from all the subarrays will be some numbers in it. We have to take the difference of the maximum number in that subarray and the minimum number in that subarray, and that difference should not be more than the given limit, and we have to find the length of the longest such subarray. So here you can see through this example, if 8247 and our limit is 4. So first of all we can just take 8. So 8 minus 8, max is 8, min is 8, 8 minus 8 0, of course less than 4. So the maximum length we have found is 1 for now. Then you can do 8 2. 8 minus 2 will be 6, which is greater than 4, so we can't do that. Now again 8 to 4, yes, cause 8 minus 4 is 4, but we cannot do 8 to 4 because maximum is 8, minimum is 2. Maximum is 8 and minimum is 2, therefore the difference will be 6, so again it will not be any good. Again 8247 is also not good because 8 8 is maximum, 2 is minimum, again it is 6. So finally you can see is either it's 4 7 where the difference is 3, which is less than equal to 4. Also you can do 2 and 4, the difference is 2. So the maximum length we can find which is within the limit, the absolute difference is within the limit is length 2, so the answer will be 2. So now we can write a try brute force, which is pure brute force, that we can check all the subarrays, but that will take us uh, time complexity of n square, and the constraints are length can be 10 raised to 5, and n square will be 10 raised to 10, and if it and generally the time limit given is 1 second. So for in 1 second you can you can perform 10 raised to 8, and 10 raised to 10 exceeds that, so it can give you a TLE in case, but we can solve this in much less time. So we will take this approach, which is the right pointer and left pointer approach. So what you will do, so the red one is the right pointer and left one is the left point, red is the right pointer and black is the left pointer. Now we will keep on increment the right. We'll keep the right fixed. First it will be on 0th index, then it will be on the first index, then second, till the array ends. And once red is fixed, we'll just keep on moving our black, that is our left pointer, until and unless we hit the condition, that is we get the absolute difference within the limit. So for this example you can see limit is 5 and our given array is 10 and 1. So firstly both left and right will be on the 0. So right now the difference will be difference will be 10 minus 10 because maximum of 10 and 10 is 10 and minimum is also 10. So this will be 0. So current length, maximum length is 1. Then again move the right pointer. Now see, is this within limit? Current left pointer, is it within limit? So 10 minus 1 is 9. 9 is greater than 5. So no. Then move left pointer. So now again they both are same. So 1 minus 1 is also 0 and length will not change, but we will take the maximum of the previous length and the current length, the current found length, and that will give us the answer. So how we will code this? So the implementation for this, we use DQ, a double-ended queue. Why DQ? Because when you will see the whole algorithm, which I'll explain now, you will find that we need to have operations on the both end of the data structure we are using. That we need to also add and pop from the back and also add and pop from the front. And double-ended queue is a data structure that gives us the freedom to have efficient operations on the both end of the data structure. So that's why we are using DQ here. And how we will solve this? So there are two parts. Firstly, we will declare a left equal to 0 and answer equal to 0, and also a for where a right is will be initially 0 and it will go till the end. Let us take this example for our understanding and also the limit. Okay, this is our limit, this is our answer, and we will need a we will need two queues. One is max DQ and second is min DQ. So this one's max DQ, this one's min DQ. So first of all, left is 0, right? Answer is also 0. And why this is? So this for loop, let me show you here. Here you can see it clearly. In this question, you will see that this for loop wraps the whole thing. Why? Because for loop is controlling the right. That is what I just explained. That right will just keep on increasing, just one index incrementing, and we will adjust the left until and unless we get a valid subarray. So inside this for loop, we'll use bunch of while loops and conditions to check if the left is valid for the thing. So this is the whole approach and the whole bigger picture. So let us see the parts of it now. So right now left is 0. Uh, Let me also take our left and right. Yes. So right now left is 0, also right is 0. What we have to do? We have to do for int right 0, right less than nums, and answer is 0. Let me also track the answer. Right now it's 0. Maintain. So first of all, what we have to do? Maintain a decreasing queue maximum while dq not empty and nums max dq dot back less than max dq push back correct. So what this while loop is doing? It's maintaining a decreasing dq, a monotonic queue which is decreasing. So how it will act? So if nothing is present, so right now nothing is present, so we'll just simply push back right. Right now right is pointing to 0, and we are not pushing nums right, we are pushing right, that is we are maintaining the index. And why we are maintaining index? Because uh, once you get to the further algorithm, we if we use values here, we will we cannot traverse to the nums array when we want to pop something and check for the next number, and so on. So right now 0 will be added, and again there will be also minimum, and also minimum the same thing will be added. There is nothing to compare, so we'll just simply push back right in both the things. So let me give you right now here the further thing uh, for the algorithm is there, but let me give you an idea of how this overall maximum dq and minimum dq will be maintained. So how it will be maintained? Now right will traverse the whole thing, and here only right value is concerned. We are not checking anything left in here. Left part is downside. So how it will be maintained? Now the next time it will go to 2. Now what it will check? Nums max dq dot back. That is right now this is 0 less than nums right. So is nums back, what is that? Nums 0 is 8. Is 8 less than 2? It is not less than 2, right? Nums max dot dq dot back, that is nums right 0 is less than right, it's not less than right. So we will just do max dq dot pop back, and here we are maintaining the uh, here maintaining the decreasing dq. So we are checking if it is less than. So right now it is not less than, so we'll just simply push back our 1, that is the index of our right. Then again it will go front. Before that we will also do this increasing dq. This is our min dq. So this is the increasing one. So while not empty, yes, it's not empty. Nums back, that is right. Nums 0 is 8. Greater than nums right? Yes, it's greater. So if it's greater, what we will do? We will pop it and then add our current thing. Go further. Now again, nums max dq dot back less than nums right. So we have to check the back. So in the back the value is 2, not nums back value is 2. Is 2 less than 4? 2 is not. Yes, 2 is less than 4. So we will, what we will do? We'll pop this and add the index, because 2 are less than 4. Now again here is 1. So this is 2 here. So is 2 greater than 4? No, it's not greater than 4. So we'll just simply add that here. Again go to 7. So now here the value is the index is 2. So that is 4. So it's 4 less than 7. 4 is not less than 7. So we'll just simply without popping add the thing. But is 4 less than 7? 4 Wait a minute, sorry, 4 is less than 7, so we will pop 2 and then add 3. And is 4 greater than 7? 4 is not greater than 7, so we will just simply add the index. So this is how universally this maximum and minimum DQ will be maintained. Then going further, what we see here, shrink the window when invalid. So that is this thing, that once right is fixed, we will shrink the window from the left side if it is invalid. So that we will shrink the window until and unless we get to a valid part. So while nums max dq dot front minus nums min dq dot front is greater than the limit, what we will do, remove the indices that leave the left. That is, we will check if max dot dq is equal to our left, the left right now was 0. So here it was 0, and also here it was 0. So right now the our left is 0. So we will check on whose left side it is, and we will just pop that from both the appropriate values and then just increment our left, that is shrink our value until and unless we find a valid thing. Once we find a valid thing, we'll just increment our update our answer by max of current answer and right minus left plus 1. What is right minus left plus 1? The current length of the subarray. Current length of the subarray is right minus left plus 1. And in such fashion, we can iterate the whole thing, like right goes to the next index, then again this whole process, to the next index, whole process, left index, whole process, until it gets to the end. Once it gets to the end, there are no further things to check, and we just can simply return the answer. And what this maximum and minimum DQs allow us, they allow us to track the values, the minimum and the maximum values in the subarray efficiently. That is, they allow us to check the values really efficiently. We did not to check the whole subarray again for minimum and maximum, as we are maintaining these minimums and maximums traversing through the array. So for a specific subarray, we can just simply check if they are equal to front in both the queues, and with that we can get the idea of how do we need to update the left. And this is the approach and solution for the question longest continuous subarray with absolute difference less than or equal to limit using q. Thank you.